Okay, so I recorded it, made a beautiful video, and once again my program shut down on me. So we're going to try a different program. Hopefully that doesn't happen. I am doing 8.2, day 2, quick review of 8.1. Those domain and ranges, don't forget about them. Make sure you're looking at your original equation saying, hey, when is this going to be equal to 0? So in this case, when x equals 0, that is not going to be included in my domain. The simplifying works very similar to what we're about to do in the next part of the lesson, so I'm not going to go through that part. Okay. First thing with this, lesson 3. Oh, mouse is on the screen. There we go. Simplifying rational expression, the domain and range. We'll talk about this a little bit at the end of the video, but I'm mainly going to be focused on this multiplying part. Oh, sorry, I got a text and I wanted to make sure it wasn't important. Okay, key points here. Multiplying, these are just the steps we're going to do. The first one is always going to be to factor here. The second one is going to be kind of a combination of these two. Because if I have common factors, I can get rid of them before I go in and multiply, like it says to do here. So, next thing it says, hey, rewrite this 1 minus x. You can rewrite this as a negative x minus 1. To do that, you just say, okay, if I have 1 minus x, let me switch where these are written. So my x is going to pop over here, my 1 is going to pop over here. The negative is attached to that x, so it's going to go with it. Negative x plus 1. Now, factor out that negative. Negative x minus 1. Sorry, I'm still very sick. So, if it helps, you can think about this too. Say if I were to go back and distribute this in, I still get a negative x plus 1, which if I switch the order, gets me back to a 1 minus x. So, multiplying rational expressions. Part A. What we need to do is group these together. So I'm going to take my constants from the top and the bottom and put them together in one fraction. So that 8 and the 7 are going to come together on the top, 8 times 7, and it's going to be divided by the 2 times the 4. So what's on the top stays up top, what's in the denominator stays in the denominator. Now, times, I'm going to bring all of my x's together. So I see an x cubed and an x to the 4th. Those are going to come up here. On the bottom, I only have the 1x. That goes here. Lastly, my y's, I have a y times a y cubed divided by a y squared times y. So what I need to do is I need to go through and cancel stuff out wherever I can. Key thing with this 8 is that's the same as a 2 times a 4 here. So really what's happening is I'm saying, oh, this 2 is canceling, this 4 is canceling, so all I have left is the 7. So, first part, okay, I know I have 7. Now with my x's, I need to go, I have one x here on the bottom, and I have an x cubed and an x to the 4th on the top. So, when I divide, I subtract exponents. This is technically a 1 here. So if I have a 3 minus 1, well, that's canceling this out and just reducing this 1, or this 3 by 1. So now I'm going to have my x, and I'm just going to be doing my addition rule now because I only have multiplication here. So the 2 and the 4 come together, going to be an x to the 6th. Lastly, with the y's, I actually have with this y squared times y, another y cubed on the bottom, with this y cubed on top. So this cancels each other out completely, leaving just the 1y behind. So times y. If it helps to see this better, really what I'm doing here, these pens keep rolling, is I have a y times a y cubed, so that's the same as 3 more y's, divided by a y squared, so 2 y's, times 1 more y. So these cancel, these next ones cancel, and the last ones cancel. So I just have 1 y left, which is the y you see right here in our answer. So, question 5 is very similar. The constants work out a little different, with that one. So what I recommend doing is saying, okay, I'm still going to group those constants together. I have a 3 times 6 divided by an 8 times 9. But once again, this 6, well, that's the same as a 2 and a 3 together. This 8 is the same as a 2 and a 4, and this 9 is a 3 times a 3. So really I could say, oh, there's a 3 here and a 3 here, a 3 here and a 3 here, and a 2 here and a 2 here. So I'm actually only left with a 4. These are all disappearing, even the 8, and a 4 is left behind. So first part of your answer should be a 1/4 here, and then you'll have your x and your y to some power. Okay, 4b here. First thing is to factor this top part out. So 3x minus a 3x squared. What we need to do here is say, okay, I have a 3 times an x minus a 3 times an x times an x. So these both have a 3x in them. That's going to be divided out and come up front as a factor. So I'm going to have a 3x in the front, that's what I circled, and then I say, okay, what did it leave behind? Well, if it left nothing behind when you're dividing, that placeholder is a 1. Minus, well, the 3x is disappearing, but it leaves behind an x. So I've dealt with my numerator, I'm going to deal with my denominator now. For this one, we need to factor with a t-chart. So I'm going to say, okay, what multiplies to this last term? -5. But adds to this middle term, 4. So I'm going to say, okay, well, 5 times -1, that gives me a -5. But also, a 5 plus a -1, well, that gives me 4. So my factors in this case are going to be an x plus 5 and an x minus 1. Now, for my next set, in my numerator here, I need to use a t-chart to factor this again. So I'm going to say, okay, what multiplies to -20, but adds to a +1? In this case, it's going to be a 5 times a -4. Because 5 minus 4, well, that gives me the +1 that I need. So here on the top, I'm going to have an x plus 5 and an x minus 4. On the bottom, we're going to do that 3x. So now here, okay, we see a 3x, we see a 3x. Those can cancel. Next, I see these x plus 5s. X plus 5, x plus 5. These can cancel. So I'm going to call it good there and rewrite it here. Some of you might be saying, hey, but what about this 1 minus x and x minus 1? We're going to work with that next. So we have the 1 minus x and the x minus 4 all over an x minus 1. So these aren't quite the same yet, but they look similar enough. We're going to be like, hey, I think I can do something with this. Well, that was what we talked about right here. We're going to rewrite it as a negative x minus 1. So, equals negative x minus 1 times an x minus 4 all over an x minus 1. Now, okay, I'm back to having these two things be the same. They cancel out. Final answer, I'm just going to take this negative, distribute it into here. So we have, at the end, a negative x plus 4. Now for C, this last one, the key is seeing that cube. When you see a cube, you always want to go through and factor first. Sorry. My throat is still not happy. So whenever I see an a cubed minus b cubed, I don't know why I put parentheses around that. You don't need them. I can rewrite that as an a minus b times an a squared plus a times b plus b squared. So, what we need to do, we need to say, hey, I recognize that this x cubed is here minus a 27. So that's going to be able to correlate with this. They look very similar. So what I need to do is figure out how to write this 27 so it's something cubed. So what is the cube root of 27? 3. So 3 cubed is here now, so that tells me, oh, my a value is x because that's my first term, and my b value is 3 because that's the second part here. So when I'm rewriting this, I'm also just going to plop this up onto the numerator because it's multiplication. So x plus 2, x squared plus 3x plus 9, all divided by x minus 3 times an x squared, because of my a squared here, plus a times b. Well, that's x times 3, but I can flip that. I can write it in any order. So I'm going to write it as a 3x because I like my variables going last. And then plus a b squared, so that's a 3 squared or 9. Well, if I look at it, these two are the same thing now. So the reason I did this was I was hoping, hey, maybe I won't have to factor this and it can actually cancel with the quadratic that comes out of my cube. And it does. So this cancels. Our final answer here, x plus 2 divided by an x minus 3. Be really careful. A common mistake I see, even some of my calculus kids will do this, is they see these x's and they want to cancel it out. Don't do that. Because of the addition and subtraction here with no multiplication, we can't cancel anything left here out with each other. Our final answer has to include the x plus 2 on the top and the x minus 3 on the bottom. The last thing I'm going to do is just talk a little bit about those domain and ranges here. So if I go back to example A, I need to say, hey, I'm going to look at these denominators and determine what my domain and range are. So my domain is going to be based off of my x values here. But it's all multiplication. There's no addition in here, so it's just actually going to be x cannot be 0. And for my range, I have y's in the bottom, but once again, there's no addition or subtraction, so y does not equal 0. Now for b, though, domain, we'll do here. I need to look back here before I started really canceling too much out. So I'm going to say, hey, x plus 5, x minus 1, and 3x. Well, we'll do the domain in blue again. My x for x plus 5, if I was going to make that 0, I would need a negative 5. So x cannot be that value. Next, for the x minus 1, well, if that was going to be equal to 0, I would need a positive 1. So x cannot be that value. And lastly, the 3x, if that's going to go to 0, x cannot equal 0. So boom, there's my domain. There's no y value, so I don't have to worry about a range here. For C, once again, just a domain, no range, because there's no y values. Domain, I'm going to be looking here, not in my simplified form. X minus 3. Okay, well, if my x value was 3, it would go to 0, so that can't be true. And actually, if I look at this rule gives us our most factored form, meaning this has no real solutions. They're all imaginary. So we don't actually have to worry about that in terms of our domain. This is the only one we have in terms of our restrictions for our domain for that one. So if you haven't yet, go ahead, try these 3 practices, And then if you did do them because you were in class, go ahead and actually try and find the domain and range, depending on what problem you're on, for these 3 problems.